Also 5.1, we're going to be looking at simplifying rational expressions. All right, so a little property that'll help us in this section is for exponent rules. So this is what we call the quotient rule of exponents. So the quotient rule tells us if we have an expression such as a to the m over a to the n, then to simplify that, we subtract exponents. So it's going to equal a to the m minus n. Now, if the exponents are bigger on bottom, this ends up being negative. So we also got a negative exponent rule. So the negative exponent rule tells us if we have a variable with a negative exponent, we sort of flip by putting it under a 1 and making the exponent positive. So it's like you move it down, change the sign of the exponent only. Also, say the exponent's in the bottom negative. If the exponent's in the bottom negative, then we flip it and basically move it to the top and make the exponent positive. So negative exponents, you either move it down to make it positive. If it's on the bottom and negative, you move it up and make it positive, okay? Because that can happen sometimes when you subtract the exponents, because it's usually the top exponent minus the bottom, okay? But I'll show you some tricks when we're working these. So y'all, the first example say simplifying by removing factors of 1. So what they mean by that, anything on top can be simplified by removing the same factors from the bottom. So let's look at one of these. I got 72 y to the 9 over 8 y to the 4th. So first I would start with my numbers. Now, if the number divides, divide it. Otherwise, you have to try to simplify it. But y'all, 72 will divide by 8 and make a 9. So that's basically going to be a 9 on top and a 1 on the bottom. So basically, we're dividing both of these by 8 so that I get a 9 on top and then a 1 on the bottom. Now, with the variables, I'm going to subtract the exponents. So I got my y. So remember, it tells me to take the top exponent minus the bottom. So that'll be 9 minus 4. So y'all, let's see what that gives me. So I'm going to have a 9 on top. So really, I don't need the 1 on the bottom because we can get rid of a 1 on bottom because anything divided by 1 is itself. So let's play with the variable and see what happens. So I got my y. 9 minus 4 gives me 5. So technically, that's all over 1, but remember, I don't have to write a 1 if it's on the bottom. Now, since my exponent's positive, we would be done. So if that would have been a negative exponent, then I would have had to use this rule and move that exponent down, okay? All right, y'all, same thing, simplify by removing factors of 1. I got a 3d minus 9 over 3. So what we're going to do here, anytime you got two terms like this being separated by adding or subtracting, you want to try to factor out a greatest common factor. So for my top, 3 and 9, the greatest common factor would be a 3. So you would factor out that 3. So this is going back to last test you had. Now, if you divide a 3 out of both of these, that'll leave you a 1d minus 9 divided by 3 leaves me a 3. All of that over a 3. So now you got a 3 on top and a 3 on bottom. Those 3's will cancel out, leaving us our final answer of d minus 3. And y'all, since that's all that's left, I don't have to keep that in my parentheses. And this is what they mean by removing factors of 1, because 3 divided by 3 basically is 1. So you're removing that factor, okay? So y'all watch this. 6y minus 12 over 6y plus 12. So both of these have what we call binomials, 2 terms. So we're going to factor GCFs out of the top and the bottom. So on the top, 6 and 12, that greatest common factor would be a 6. So if I factor out a 6 of both of these, I'm left with a y minus 12 divided by 6 is 2. So do that to the bottom now. It looks like it's going to have the same GCF of a 6 on this one. So we'll factor out a 6. So 6 divided by 6 leaves me 1y plus 12 divided by 6 leaves me a 2. So y'all notice what happens again. 6 divided by 6 is a factor of 1. So I'm going to divide out the 6's. And that leaves us a y minus 2 over a y plus 2. Now, we cannot cancel anything on this because they're both not being added or both not being subtracted. When you got binomial factors, they got to look exactly the same for me to cancel them out. So since one's minus and one's plus, this don't simplify no further, and that'd be our final answer. All right, y'all, p squared minus 16 over p squared minus 8p plus 16. So both of these, since these are p squareds and p squareds, both of these will factor in the 2 sets of parentheses. So remember, this is the difference of perfect square stuff. So remember, perfect squares, p squared gives you a p and a p. The last number is negative, so you got a positive and a negative. And then remember, we found the square root of 16 to get our 2 numbers. So the square root of 16 gave me 4 and 4. So remember, difference of perfect squares always factors into conjugate pairs. Now the bottom, we'll make 2 sets of parentheses. I got a p squared, that'll be a p and a p. The last number's positive. Since the last number's positive, both of these factors have the same sign as the middle number. So both of these will be negative. And then we want factors of 16 that'll add and get an 8. Well, y'all, that'll be a 4 times 4. So we'll put a 4 and a 4. Now, if you notice, I got a p minus 4 on top, and I got two p minus 4s on the bottom. This one p minus 4 can only cancel with one of these p minus 4s. So I'm just going to cancel the one that's right under it. So these p minus 4s cancel out. So look what's left. We got a p plus 4 on top over a p minus 4 on the bottom. So y'all, the trick on this section is really being able to factor, like I factored out the greatest common factor on 2 and 3. And then 4, we had to actually factor this into 2 sets of parentheses. Y'all, let me do one more of those and then we'll do some multiplying. So 5, I got a y squared minus 7y plus 6 over y squared plus 7y minus 8. So once again, y squareds means we're going to factor these into 2 sets of parentheses. So the y squared puts a y in the front of both of these. The top one's positive at the end, so both of these will be negative like the middle. And then I want factors of 6. That'll add to get me 7. That'll be 6 and 1. Now the bottom, I got a y squared, so that'll be a y and a y. But y'all, this last number is negative. So anytime the last number is negative, you had one positive and one negative. And then we need factors of this last number that subtract to get 7. That'll be 8 and 1. And remember, the larger number has to be positive like the middle. So the 8 is positive and the 1 is negative. And you can tell you're factoring them right because look, the y minus 1 and the y minus 1 will cancel. If you get the signs wrong on these, then they're not going to cancel for us. So y'all look what's left. On top is a y minus 6. On bottom, a y plus 8. So y'all, this is just really a lot more factoring work. So let's do some multiplying. So these next examples will say multiply and simplify. So watch what we got. I got an x to the 5th over 5x plus 45. That's going to be times 3x plus 27 over 3x to the 8th. So the x to the 5th and the x to the 8th, we'll take care of that using our exponent rule. But what we got to do is factor this binomial here and factor out that binomial there. So y'all gonna bring over that x to the 5th. Can't do nothing with it at the moment. But the 5x plus 45, we can factor out a GCF on these two. Both of these will divide by 5. So we're going to factor out a 5 and see what's left in our parentheses. So 5x divided by 5 will leave us an x plus 45 divided by that 5 leaves a 9. On the top right, 3 and 27 will both divide by 3. So we're going to factor out a 3. So let's see what we get in our parentheses. 3x divided by 3 leaves us the x plus 27 divided by that 3 gives us a 9. And then y'all, I can't do none with this one, so I'm just going to bring over my 3x to the 8th. So y'all, let's see. The x plus 9 right here will cancel with that x plus 9. This 3 will cancel with this 3. So let's see, no matter what, on the bottom, we're going to have a 5. Now, with the x's, we're going to do x 5 minus 8. Because remember, it's the top minus the bottom on those. All right, y'all. So 5 minus 8 gives me x to the negative 3rd over 5. But y'all remember, I can't have negative exponents. So this variable will have to go to the bottom so that I can make the exponent positive, which means there's going to be nothing left on top. So on top, we have to have a 1. So bring over your 5. And then remember, moving that x to the bottom makes that negative 3 into a positive 3. So y'all, nothing else we can do with that. Final answer. So notice, binomial terms, I factored out the greatest common factors. On the variables, I'm just subtracting exponents. But y'all, here's another trick you can do. At this point, since the 8 is larger than the 5, you can subtract 5 from the 8 and keep that answer in the bottom. So 8 minus 5 would have left me at 3. So then I would have had an x to the 3 in the bottom, and my exponent would have been positive. So the trick really is to subtract the smaller exponent from the larger exponent, and the variable will stay where the larger exponent was at. Now, are you noticing? Any factor on either one of these tops will cancel with the same factor on either one of these bottoms. Okay? So number 7 here. Z squared minus 16 over 6z plus 18 times a z plus 3 over a z minus 4. So this one I'll factor into 2 parentheses. This one, I'm only going to factor out a GCF. And y'all, these two, I can't do nothing with at the moment. So let's mess with our z squared minus 16 first. Z squared will give me a z and a z. Last sign's negative, so I get a plus and a minus. And then remember, square root of 16 is 4, so that gives me a 4 and a 4. So remember, that's perfect squares again. Anytime you got a z squared, x squared minus a number, you're going to have perfect squares, and they're going to factor into conjugate pairs. Now, 6z plus 18, we're factoring out a greatest common factor. And the greatest common factor of 6 and 18 would be a 6. So if we divide a 6 out of both of these, that'll leave me a z plus 18 divided by 6 gives me a 3. So then can't do nothing with the z plus 3. Can't do nothing with the z minus 4. But at this point, anything on either top can cancel with the same thing on either bottom. So notice, I got a z minus 4 that'll cancel with that z minus 4. I got a z plus 3 that'll cancel with that z plus 3. So all that's left is a z plus 4 on top over a 6 on the bottom. Okay, so the name of this game is factoring and then canceling out common factors. So y'all, the next one says divide and simplify. So I got number 8 here. I got 18x to the 7th over 2y to the 4th divided by 81x squared over 6y squared. So the first rule about dividing fractions is we don't like to divide fractions, so we change to multiplication and flip the second fraction. So change to multiplication and flip the second fraction. So then it basically will turn into a multiplication problem. Now you cannot cancel anything while you're dividing. You got to change it into multiplication first. Once you change it into multiplication, then you start trying to simplify, okay? So we leave the first fraction the same. I'm going to change the multiplication now. And we're going to flip the second fraction so that we get the 6y squared on top and the 81x squared on the bottom. All right, y'all. So I'm going to start playing with numbers and seeing who's got anything in common. 18 and 81 will both divide by 9. So we're going to take out the 9s, make that a 2. And then 81 divided by 9 makes that a 9. Well, y'all look at this. These two 2's will cancel now because I got a 2 there and a 2 there. So let's see. I got a 6 and a 9. 6 and a 9 will both divide by 3. So if you divide by 3, that gives you a 2 on top and a 3 on bottom. So you just got to keep playing with these numbers and canceling out any factors that you can. So y'all notice on the numbers, there's nothing else I can do. So on top, I will have a 2, and on bottom, I'll have a 3. So now let's see what we got. I got an x to the 7 on top and an x squared on bottom. So for my x's, I'm going to have x to the 7 minus 2. Now the y's got a bigger exponent on the bottom. So if you want to avoid having negative exponents, since the y is bigger on the bottom, we'll take the 4 and subtract 2 from it. Okay, because if we did it on top, remember 2 minus 4 would have gave me a negative 2, and then I would have had to bring it down to the bottom. So if you take the bigger exponent and subtract the smaller exponent, you'll have positive exponents and you'll be done. So here we go. We got 2 to the x. 7 minus 2 leaves us 5. On bottom, I got my 3. And then my y, 4 minus 2, leaves me 2. All right. X's had a bigger exponent on top, so they're on top. The y's had a bigger exponent on bottom, so they stay on the bottom. All right, y'all. So let me try one more of these. So this one has a 3z plus 3 over a z divided by a z plus 1 over a z. So remember, the first thing I'm going to do, change this to multiplication and flip the second fraction. So I got my 3z plus 3 over z multiplied by a z over z plus 1. All right, so the only one I can do anything with is this 3z plus 3. I'm going to factor out a greatest common factor of a 3. So that'll give me a 3. A z plus 3 divided by 3 is a 1. Over my z times my z over my z plus 1. So let's see what happens. That z plus 1 will cancel with that z plus 1. This z will cancel with that z. And y'all, all that's left is our 3. So y'all, that's the trick on simplifying. When you multiply, factor everything, and then start canceling your factors. When you divide, turn it into multiplication, flip the second fraction, and then you can start canceling, okay? All righty, so let's go to, let me move my camera back up. All right, y'all, so next will be 5.2. And this is adding or subtracting rational expressions. So remember, when you're adding and subtracting fractions, they gotta have a common denominator on the bottom. So our first few examples are going to be figuring out how to find a least common multiple, they call it, or least common denominator. So finding the least common multiple. And we'll abbreviate that to LCM. So it's the same thing as the least common denominator. So the first thing you're dealing with numbers. So with numbers, the least common multiple consists of all factors from either number. So let's write that. Least common multiple consists of all factors of each number. Now, say one's got 2 7s in it and one has 1 7. If you got repeating factors, so if you got repeating factors, then we use the factor that occurs the most in either number. So what I mean, if one number has 2 7s and one number we factored out had 1 7, our least common multiple would have 2 7s in it. We got to go with the repeating factor that occurs the most. Now, with variables, All variables must be represented. So X's and Y's, if one's got X's and one's got Y's, we have to have X's and Y's in our least common multiple. Now, if repeating variables, then we use the one with the highest exponent. So what I mean there, y'all, if you got an x to the 5 in one denominator and an x to the third, their least common multiple has to have the x to the 5 because it happens the most. It's got the highest exponent. So y'all, these first few examples, we're going to find the LCM by factoring. So for number one, I got 245 and 175. So what you got to do with these two numbers is make a factor tree and break them down into what we call prime factors. So let's start with 245. We know 245 will divide by 5. So if I take 245 and divide by the 5, that leaves me a 49. Now the 5 is a prime number, but the 49, we can factor that down further. We can factor that 49 into a 7 and a 7. So the 5 happens once, and then the 7 happens twice. And then I can't go no further because now I've got it into all prime factors. So then I do my 175. Well, I know 175 will divide by 5. Anything that ends in a 5 will divide by that 5, okay? Now, if you divide 175 by 5, you're going to get a 35. But y'all, 35 will break down further. So 35 will break into a 5 and then a 7. So now let's see what we need in this least common multiple. So let's compare the 5s first. Here you got 1 5. Over here, you got 2 5s. Remember, we said up here, if repeating factors, then we use the factor that occurs the most in either denominator. Well, since the 5s happen twice over here, that means I need 2 5s in my least common multiple. So now I'll compare the 7s. Over here, I got 2 7s. Over here, I got 1 7. So it happens the most in this denominator, and it happens twice. So that means I need both of them 7s in my denominator. So notice, repeating numbers, we went with the most. And then the 7s, I went with 2 7s because it happened twice on that one. Y'all, if you multiplied all this together, you would get 1,225. So y'all, let me say, before I do the next one, do any of y'all use a TI-84? All right, so none of y'all are using TI-84s? All right, let me see my chat. Let me see my chat. Okay, so you know, that's cool because then that's what we want to do. We're just going to break down the numbers until we find numbers that happen the most in either of these categories. Okay, yeah, so Paris, if you don't have one, you can actually download the app from your app store like Bree did. So let me show y'all a way you can do these on the calculator. So let me share my calculator. So if you got a TI-84, even the phone apps will work. To find the least common denominator, it'll do two numbers at a time on here. So what you do is you hit this math button and arrow right until you got the number row highlighted. Once you highlight that number row, arrow down until you find LCM, which is our least common multiple. So you'd hit enter on that, and then you just put your two numbers. I had 245, comma, there's a comma right above the 7, and then my second number was 175. So y'all, when we hit enter, it'll give us the least common multiple of 1,225. Okay. All right, so let's see what my number 2 is. So this one has three numbers: 49, 21, and a 3. All right, I got a chat popping up. Let me see what it's saying. Okay, good job. All righty, y'all. So let's play with my 49 first, and then I'll do my 21, and then the 3. It's pretty much a prime number, so we're good on it. Now on the calculator, you can only do two numbers, so I would do the 49 and 21, because the 3, since it's a factor of 21, you're covered if you use the two larger numbers here, okay? So y'all, let's see, 49 will break into a 7 times 7. 21 is a 7 times 3, and then the 3 is pretty much a prime number. So to find our least common multiple, I'm going to start with the 7s. So I got 2 7s right here and 1 7 here. The most it happens is twice. So my least common multiple will have to have both of these 7s in it. And then the only other factor I got is a 3. It happens once in this number, and it happens once in this number. So the most it happens in any of my 3 numbers is 1 time. So I need only 1 3. So if we multiply all this together, I think we get 147. So let's go back to the calculator, and I'll show you that if you use 49 and 21, you're covered on that. So remember, I'm going to go to math, arrow over to number, and then arrow down to find my LCM. Hit enter. And then my number was 49, comma, 21. So y'all, once I hit enter, I get our 147. So by hand, the trick is just actually breaking these into factor trees, I call them, okay? So let's throw some variables on these. I got a 21, C5, B8. I got a 7, C5, B5. And then I got a 15, C5, B8. So the trick is the numbers, because the variables, I'm going to pick which variable had the highest exponent and put that into my least common multiple. So what I got to do is play with these 3 numbers, 21, 7, and 15. Now the 7 is prime. We're not doing nothing with it. 21 would be what? 7 times 3. And then 15 would be 3 times 5. So our least common multiple, first I'll start with the 7s. I got a 7 here, and then I got 1 7 here. But the most it happens in any of my 3 numbers is 1 time. So I'm going to bring down my 7. So then we'll pull with the 3s next. of my threes, I got 1 3 here and 1 3 here. The most it happens is one time in any of my numbers. And then y'all, the last number would be the 5. Remember, all factors have to be represented. And the 5 only happens once in this one, none in the other two numbers. So the most that the 5 happens is one time. Now let's look at our C. All of these are C to the 5th. So automatically we bring down the C to the 5th because that's the highest exponent. And then on our B, I got a B8, B5, and a B8. The highest exponent is the ones with the 8. So we bring down our B to the 8. So the variables are done. All I got to do is multiply these numbers together and see what I get. So let's see. 7 times 3 times 5 gives me a 105 C5 B8. Now, if I was using the calculator, I always do the biggest numbers because 7 is a factor of 21. So if you do on the calculator 21 and 15, it'll give you the 105. And then you just got to play with the variables. Every variable had to be represented, and we picked the one with the highest exponent, okay? So I'm going to flip that over and try one more of those. So let me do this one. I forgot what number I'm on. I'm on number 4. So this one has 20 x to the 6th, z to the 7th, and then it's got a 4 x to the 4th, z to the 3rd. So let's play up our numbers. We got a 20 and a 4. So 20 can be 5 times 4, but y'all, the 4 will break into a 2 and a 2. Same thing with this 4. It's going to break into a 2 and a 2. So our least common multiple, let's start with we need a 5 no matter what. And the most it happened was one time. Then we need some 2s. But y'all look, the 2s happen twice here and twice here. So that means we need at least 2 2s because the most it happens is 2 times. Now let's play with our variables. We got x's. So on the x, we want the highest exponent between the x's. So I got a 6 and a 4. The highest exponent would be the 6. And then I got z's in both of these. And the z has the exponent of 3 and the exponent of 7. Largest exponent would be the 7. So y'all, 5 times 2 is 10, times 2 gives me 20. X to the 6, z to the 7. So let me box that in so it don't look like it's on with that other part. So y'all, here's a little trick. If your smaller number is a factor of the larger number will automatically be the least common multiple, okay? All righty, so the reason we had to find least common multiples is so we could add or subtract. So these next examples will say, and let's see, I think there's only a couple of these. So these will say add or subtract, then simplify. So this will be my number 5. Now, they were nice and ours already have a common denominator. So we don't have to worry about finding the least common denominator because ours will already have them on these two problems. So x minus 4y over x plus y plus, I got it, x plus 9y over x plus y. So remember, when you add fractions, no matter what, the bottom, since I got a common denominator, in my answer, the bottom will be x plus y. So remember, you bring the common denominator over, and all the work gets done on top. So what I'm going to do, I got x minus 4y plus x plus 9y. So all the adding and subtracting gets done on top, and you put that over that common denominator. So y'all, what we got to do now is add like terms. You got an x here and an x here. X plus x will give you 2x. You got a negative 4y and a positive 9y. So 9 minus 4 leaves me a positive 5y. All of that over our x plus y. And y'all, that's a trick. You'll have two doing that. So let me try this last one. 2x minus 2y over x plus y plus 3x plus 9y over x plus y. So we're not killing you with too much adding and subtracting on these. And they're both actually adding, wasn't no subtraction on these, okay? So remember the bottom, common denominator, x plus y. So the bottom of my answer will be x plus y. And on top, we do our operations. So we got 2x minus 2y plus this 3x plus 9y. Now we know the bottom will be x plus y. All we got to do on top is add like terms. So you got 2x that'll add to the 3x. So 2 plus 3 gives us 5x. And then we got a negative 2y plus 9y. So basically that's 9 minus 2, which will leave us a positive 7y. All right, y'all. So that's all we're going to do to you on adding and subtracting. So you'll have a few more than I did on the LCM. But remember, break them numbers down. And when you got common numbers, go with the most that happens in either denominator. Well, this only happened twice, so I picked 2 of them, okay? And then the 5 happened once. None over here, but it did happen at least once here, so you had to pull that 5 out also. So not too bad. You just got to be able to break them numbers down, okay? Now, if you got a calculator or even the phone app with that calculator, go to math, arrow over the number, and then go down and find that LCM on it, okay? All righty, y'all. So let me get my paper fixed. So you know the last section is going to be division. So 5.3, dividing rational expressions. All righty. So let me start with this first examples. And I'm going to sort of explain what we got to do while we're playing with this. And this will just say divide. But this one, we're dividing by single terms on the bottom, okay? So these ones will have single terms in the denominator. So y'all watch what I got. I got a 40 a to the 9th minus 35 a to the 7th plus 25 a to the 4th, all divided by 5a to the 4th. So the first thing I got to do, since I got 3 terms on top, I'm going to separate this into 3 fractions. So I'm going to separate into 3 fractions. Each of these parts on top will be over that 5a to the 4th. So you're going to have a 40a to the 9th over 5a to the 4th minus 35a7 over 5a to the 4th plus 25a to the 4th over 5a to the 4th. And at this point, we're going to simplify each fraction. Okay, so these will divide out. And then remember, on the variables, I'm going to subtract exponents. So let's see what we get. 40 divided by 5 gives me an 8. 9 minus 4 leaves me an a to the 5th. Minus 35 divided by 5 leaves me a 7. On the a's, 7 minus 4 leaves me 3. So remember, I'm subtracting the exponents on my variables. And then at the end, I got a plus. 25 divided by 5 is 5. And y'all, these A4s match. So remember, when they match, I cancel them out and I'm done. Now, nothing else we can do to that, so we're done. So let's try another one. 16a to the 8th minus 16a to the 6th plus 20a squared. Y'all, all of that's over 4a squared. So remember, the first thing, we got 3 different terms up here. So we're going to separate this into 3 fractions like we did the first one. So we'll have our 16a8 over 4a squared minus 16a6 over 4a squared plus our 20a squared over 4a squared. All right, y'all. So now we're just going to divide, and then on the variables, we're going to subtract exponents. Although at the end, we know that the a squared is going to cancel out. All right, so let's see what we get. 16 divided by 4 is 4a. 8 minus 2 gives me a 6. Minus 16 divided by 4 is 4. 6 minus 2 leaves me 4. And then at the end, 20 divided by 4 is 5. And remember, those a squareds canceled out. So not too bad when you got a single term in the bottom. Separate it into ever how many fractions you need. Remember, I'm splitting my fractions between the minuses and the pluses up here, okay? That's how I'm getting my 3 fractions. And then let's just simplify each one of your fractions to get that final answer. But y'all, what happens when we got more than one term in the denominator? So these ones will be divide. But on this, we have a binomial in the denominator, or 2 terms in the denominator. So what I'm going to show you is what we call synthetic division. Okay, so let me show you this example. So this is our what, number 3. So this one will have parentheses. Oh, well, I won't use synthetic division on this one. This one we're going to use long division, and then I'll show you synthetic. So for this one, I got 25 x to the 9 y 10 minus 40 x 7 y 8 plus a 15 x 4 y, all of that divided by 5x 4 y. And y'all, I got ahead of myself because this is just a single term in the bottom. So since this is a single term, I'm going to do it like I did on the first two. So I was looking at the wrong problem. So this will be just like the ones we just did, but they're writing it using that division. So I'm going to have 25 x 9 y 10 minus my 40 x 7 y 8 plus our 15 x 4 y, all of that divided by 5 x 4 y. So yeah, I was looking at the wrong problem, but this is still a single term in the bottom. So remember, I got 3 terms on top. So I will make this into 3 separate fractions, okay? But y'all, my next one will have 2 terms in the bottom, okay? All right, 40 x 7 y 8 over 5 x 4 y. I think what they did, they just wanted to do one of these where it was written out long form instead of already made up like this. All right, y'all, then we got a 15 x 4 y over 5 x 4 y. Well, I do know one thing. In the last one, the x4s will cancel and the y's will cancel. So the rest of these, let's divide and see what we get. 25 divided by 5 is 5. On the x's, 9 minus 4 leaves me 5. On the y, 10 minus 1. Remember, if there's not an exponent by the variable, we treat it like a 1. So 10 minus 1 will leave me 9 on that one. Minus 40 divided by 5 is 8. X, 7 minus 4 leaves you 3. On the y, 8 minus 1 leaves us 7. Then you're at the end, 15 divided by 5 gives me 3. My x is canceled and my y is canceled. So yeah, this one was just wanting you to realize that this long form of division is the same thing as the fractional form. So make this into 3 fractions and separate each one and then simplify. So now I'm going to show you long division, okay? So this will start with y'all's number 4. So I got a c squared plus 14c plus 45. We're dividing that by c plus 9. And y'all, actually on these, we don't even got to worry about this long division. Y'all might have learned that in school before. But for college algebra, you definitely want to know how to do this what I'm going to show y'all, synthetic division. So the first thing for synthetic division, you write out the coefficients. So write out the coefficients. Now, I'm only going to write out the coefficients of the first term that's being divided, okay? So there's not a number in front of that c squared. So remember, you got to treat it like a 1. So you write out the coefficients. I got a 1 for the c squared, a 14 for the c, and then a 45 for the last number. So you write out the coefficients. Now, under the coefficients, leave just a little space here, and we're going to make an upside down box. And then actually, I will square a box right under the last number. Now, over here, we call this our C. C is this number, but it's opposite in sign than what's in this factor. So since this is a positive 9, our C will be a negative 9. So remember, this is basically what we're going to be using as we go through our process. So remember, this is what I'm calling my C over here. So write C, which is opposite in sign than the factor. So y'all, synthetic division, here's the process. The first number we bring straight down. So bring the first number down. So my number's brought down. Now what I do, any number that's down here, we multiply by C to get the next column. So multiply that number by our C and put into the next column. So y'all, 1 times negative 9 is negative 9. And that's why we had to leave a little space here, okay? So now what you're going to do, you're going to add this column together. Add the column and bring that number down. So 14 and negative 9 going to give you a 5. And y'all, at this point, we're going to repeat the process. So that means this number that I brought down gets multiplied by my C. So 5 times negative 9 is a negative 45. And then you add these two numbers to get your remainder. The remainder is always in this box. But y'all, 45 minus 45 gives me a remainder of 0. So these two numbers are what we call the quotient. Now the quotient here, these are the coefficients of our quotient, and the quotient starts out 1 degree less than the original. So the quotient starts out 1 degree less than the original polynomial. And y'all, I'm going to do a lot of synthetic division examples so y'all get the idea of this. So what that means, if this was a C squared in the original, this means that this will be 1C plus 5. And they go in descending order. Now this would be our remainder. So this one would technically have no remainder. Now, in MATLAB, instead of 1C plus 5, I'll probably just put what? A C plus 5. So y'all remember, if you take this answer and multiply by that C plus 5 that we divided by, if you multiply them two together, you will get back to the original polynomial. All right, so let me give y'all a second, then I'm going to do probably about 2 or 3 more examples on this, okay? And y'all, we got a whole section in college algebra where we do synthetic division like this. So let's play with some more of this. All right, so let me move that up. But once again, these are going to say divide. Now, some of these will say divide, and then some of them will say use synthetic division to divide. So let's do this one. I got a C to the third minus 5C squared plus an 18C minus 11. We're dividing by C minus 3. So the first thing we're going to do is write out these coefficients. So remember, that's a 1C third. So I got a 1, negative 5, 18, and a negative 11. Now, if anything's missing, like if I didn't have my C squared here, I would have to put zeros down here, okay? And I got one coming up in a little bit that we will have to put zeros. So I'm going to leave a little space and draw my box. Now remember, the end box is my remainder. So since this is C minus 3, my C over here will be opposite in sign than that factor. So our C will be a positive 3. All right, so remember, we bring the first number down. Every time you do this, you're bringing that first number down, okay? Then you're going to multiply by C to get the next column. 1 times 3 is 3. So we bring our 3 into the next column. We're going to add that column. A negative 5 and a positive 3 give you a negative 2. All right, so remember, now you got this number. It's going to multiply by C to get the next column. Negative 2 times 3 give you negative 6. So then 12 and negative 6, 18 and negative 6 will give me a 12. So then I multiply to get my last row. 12 times 3 is 36. And y'all, let's see, 36 minus 11 leaves us a remainder of 25. Now remember, our quotient here, this is the quotient. This here is our remainder. So our quotient starts out 1 degree less than the C third. So that means I got 1C squared. So I got 1C squared minus 2C plus 12. So 1 degree less, and then they go in descending order. The C squared, the C term, and the number. And then I got a remainder of 25. So synthetic division is not too bad once you play with this a little bit. Now, y'all, this next one, let's see what we got. A to the third minus 8a squared plus a 6. We're going to divide that by a minus 3. So first I'm going to write out my coefficients. So I got 1a to the third, so that gives me a 1, minus 8a squared, so that gives me a negative 8. But y'all, there's not an a in here. So since I don't have an a term, my next number has to be a 0. And then at the end would be my 6. So for this one, I had to use a 0 since there is no a term. Okay. So starting from the beginning, you got to have an a3, an a squared, an a, and then your number. All right, y'all, this part's not bad. Make your box. There's my remainder. Over here will be my C. Remember, this is a minus 3, so change the sign and make this a positive 3. All right, y'all, so now here we go. Bring the first number down. Then we're going to multiply to get the next column. 1 times 3 is 3. Negative 8 plus a 3 will give us a negative 5. Then we're going to repeat. Negative 5 times 3 is negative 15. Well, y'all, 0 and negative 15 give us a negative 15. Negative 15 times 3 is negative 45. So let's see on this, negative 45 and 6, give me what? A negative 39. So here's my quotient. And then here is our remainder. All right, so let's see what we got. Remember, 1 degree less, so this means this is 1a squared minus 5a minus 15, and my remainder is negative 39. But y'all, let me show you something on this one. On this one, they write the remainder in a different way. So they bring down the quotient part. So you got your a squared minus 5a minus 15 plus my remainder is negative 39 over what I divided by, which was the a minus 3. So this one, they want you to realize that you can write this all as a single polynomial if you put the remainder over by what you divided by, okay? And y'all, that's the only one I think that they do that to. And this is just to get you sort of ready for some of the stuff you might see in college algebra. All right, y'all, so let's play with more of these. All right, y'all, watch this. W4 minus 81 divided by W minus 3. Y'all look at this. I got a W4 that's going to be 1 W4. But I don't have a 0, I mean a W3, so the W3 term will be a 0. So I'm missing a W3 term. I don't have a W squared term, so the W squared term will be 0. I don't have a W term, so my W term will be 0. But y'all, at the end, I do have a negative 81. So since I didn't have a W3 term, a W squared term, and a W, we had to use zeros for the missing terms. And I was missing 3 terms, so I had to have 3 zeros here. And y'all, I'll tell you a little trick. The highest exponent, if you add 1 to that, so 4 plus 1 is 5. That means I have to have 5 spots here. 5 numbers. Okay, so you always add 1 to the highest exponent, and that'll tell you how many numbers you need here, okay? So now we'll divide this. Remember, my remainder will be in the last box. Since that's a -3, my C will be a +3. All right, y'all, so here we go. Bring the first number down. Take that number, multiply by the C. So 1 times 3 is 3. Add this column, 0 and 3, give me a 3. Repeat the process. 3 times 3 is 9. Add that column, 0 plus 9 is 9. All right, repeat. 9 times 3 is 27. 0 plus 27 gives you 27. And then y'all finally, 27 times 3 is 81. -81 and 81 give me a remainder of 0. So here's my quotient. But then my remainder is 0, so I'm not going to have to write that this time. But y'all remember the quotient starts 1 degree less than that W4. So that means you got 1 W to the 3rd plus 3 W squared plus 9W plus 27. Okay, so remember, always starts out 1 degree less. And it's always a 1 in the front. So if you had a W4 here, that's going to be a W3, okay? And then just go down in descending order for the rest of your numbers. All righty, let's try this one. C squared minus 5C minus 36 divided by C plus 2. So I got a C squared term, a C term, and my number, so nothing's missing. Also, 2 plus 1 is 3. That means I need 3 numbers. So I got a 1 for my C squared, -5 for the C, and then my -36. I'm going to draw my box. Now remember, my C over here is going to be opposite in sign. So since that's a +2, our C will be a -2. All right, y'all. Then the fun part is actually going through this. Bring the first number down, 1. 1 times -2 is a -2. All right, add that -5 plus that -2, you're going to get a -7. And then -7 times -2 is a +14. And then -36 and 14 will give us what? A -22. So now I had a lot of stuff going on with signs here. So when I added 2 negatives, they keep that sign, okay? When you add like signs, they keep the sign and add the numbers. Over here, I had unlike signs. So I subtracted 14 from 36, which was 22, and I gave the sign of the larger number, which was negative. And then also remember, when you multiply a positive times a negative, you got a negative. But when you did a negative times a negative, you got a positive. So watch out for your signs on these. All right, so I'll write this one both ways so that you can see what I did to that one while ago. So remember, 1 degree less than a C squared means this is a C -7. My remainder was negative 22. Or I could write that as C minus 7 plus my negative 22 over what I divided by, which was my C plus 2. All right, y'all, so let's do one more of these, and then we'll be done for today, okay? So I'm going to do this last example here. Now, this one has a squared plus an 8a minus 17 divided by a plus 5. All right, write our coefficients out. We got a 1, 8, negative 17. There's nothing missing because I got my a squared term, my a term, and my number. So our numbers will be 1, 8, and negative 17. I'm going to draw my box. My C, since that's a plus 5, our C will be a negative 5. And y'all, I'll write this remainder sort of both ways too, okay? So I'll bring the first number down, 1. 1 times negative 5 is negative 5. All right, 8 minus 5 gives me a 3. Then we start our process again. 3 times negative 5 is negative 15. Now remember, we're adding 2 negatives, so that will be a negative. And then what 17 and 15 give us 32. So my quotient starting out 1 degree less means I got 1a plus my 3. My remainder is a negative 32. Or remember, I could write that as a plus 3 plus my remainder of negative 32 over a plus 5. So y'all, that's the trick. If you're dividing by a single term like we did on the first 3, separate it into different fractions and simplify each fractions. When you're dividing by 2 terms like this, we're doing synthetic division. And y'all, so I'm probably going to start doing videos for each section and probably putting them in your emails so that you're not so overwhelmed on our lecture nights. Because y'all, we went through a little bit of material tonight. Remember, we simplified rational expressions. Then we multiplied them, divided them, added them, and then we did this division, okay? So quite a bit of work here. So it's just killing us because we're only doing this 2 days a week. But I'm going to try to make some more videos and put them in MathLab so that you can sort of see some videos before I hit y'all on Tuesday night, okay? So y'all, I'm going to stop this share and see if y'all got any questions.